Now we're going to learn how to derive the trigonometric identities that there are in trig. So I need to use this stuff. This is a right angle triangle. Hopefully it's perfect. And let us say this is the angle A, this is the angle B, and this is the angle C. And so this side which faces the angle C could be called as a small or a lowercase c. And this, the side that faces it, will be called as a small c or lowercase c. And here we're going to have a lowercase b. So let us say that I wanted to express this triangle via the Pythagorean theorem. That is going to be the hypotenuse squared, and that is equal to the adjacent squared plus the opposite squared. Now here we know that the hypotenuse is obviously a c. Now you could choose the adjacent to be an a or a b. That is actually depending on whichever angle that is your choice. But there is actually not going to be no difference, because after all, you're going to have an a squared added to a b squared, which is going to be clearly the same thing as b squared plus a squared. So there is actually no difference doing that. So I'm just going to choose adjacent as a b. Well, I think I'm going to choose it as an a, just to make this stuff a little bit more chronological. So this is actually an a squared, and this is going to be a b squared. Now this is a Pythagorean theorem for this right angle triangle. Now I need to derive the trigonometric identities that could be found from this equation. So before I do that, I'm gonna take this, let's say this is theta, and let's say this is the alpha. Now if you talk about the adjacent being at a, what is the angle with respect to that from this expression or this diagram? That is going to be the angle theta. Obviously we know that if you took out the theta, you would find this is the side that lies adjacent to the angle, and also b is actually the side which is opposite. So we're going to take that with respect to sine theta. Now we know that sine theta is going to be opposite divided by hypotenuse, and the opposite is obviously an a, so that will be an a divided, well, that is a b rather, a b divided by a c. What is going to be the reciprocal of a sine theta? That is a cosine theta, well, cosecant rather. So you got a cosecant theta, and that will be a c divided by a b. Next up, we're going to try to find what will be the cos of the angle theta. So this is going to be adjacent divided by hypotenuse, so that will be a divided by a c. And the reciprocal of that is the secant theta, so that would obviously be c divided by a. And lastly, we have a tan theta, that is opposite divided by adjacent. So if you have opposite, that is a b, adjacent is an a. So if we wanted to find cot theta, that is going to be equal to a divided by b. So you need to hold these other back. Now I'm just going to rewrite this on top of this place. So this will be a c squared, and that is equal to an a squared plus a b squared. Now first off, let us say that I took c squared and divided through the whole equation by it. So let us divide through by c squared. That is going to be a c squared right here. And here we're going to have a c squared. This is also going to be a c squared. Now if I took c squared and divided it into itself, that should basically give me a 1. So we're going to have a 1 on the other side of the equation. And this is going to give us an a divided by c all squared. From the laws of indices, as far as you have these two bases carrying the same power, you could actually take the power out, and that will be a singular power. And so you're going to have an a divided by c. By the way, there is actually a video on indices and logarithm, which I've actually uploaded to the channel. So feel free to check that out to just get a refresh of the laws of indices if you actually having it rusty in your brain. Now this is going to be a b divided by c, and that will be all squared. So this is squared right there. Now, what can you say from this? With respect to the angle theta, what do you think A divided by C is going to give? Obviously, we have that. That is going to give us a cosine theta. So I'm going to write it over here. So we got a 1. 1 is equal to cos theta, and this is all squared. Now we have B divided by C. That is actually sine theta. So we need to write that there. And sine theta is all squared. Now from trigonometry, you actually have the chance to take this power and place it between cosine and the angle theta. So we should actually have this. This will be cos squared theta plus a sine squared theta. And so that will be basically it. This is a first trigonometric identity in trig. Now let us try to work it the other way. So I'm just going to take it out, rewrite it, and restart. So I think I'm going to take these out also. So let us say we have a c squared again, and that is equal to a squared plus a b squared. Now if I wanted to divide through by an a squared, that is going to be an a squared dividing through the whole equation. And so this is the a squared. Now you got c divided by a, which is actually going to be squared. This is going to give us a 1 because we have a squared divided by itself. And here we actually have a b divided by a all squared. Now we already know what c divided by a is. From here we said that is a secant theta. So I'm going to have a secant theta all squared. That is equal to a 1 plus a b divided by a. Now b divided by a is actually tan theta. So that will be b, well, that should be a tan rather. So this is a tan theta all squared. So here now we should have a secant squared theta, and that will be equal to 1 plus tan squared theta. So this is actually the second trigonometric identity that you got from this derivation. And we're going to try the last one. So we got c squared equal to a squared plus a b squared. Now here we're going to divide through by b squared. So I'm going to have a b squared. This is a b squared, and this is another b squared. Now here we're going to have a c divided by a b all squared. And on this other side, I'm going to have an a divided by a b all squared. And finally, I'm going to have a 1 on the other side. This is a b squared divided by b squared. That should give us a 1. Now, you got c divided by b. What is that trigonometric ratio that gives that expression? That clearly is cosecant theta. So that is going to be cosecant theta. Well, I'm just going to write it here. Now, you already know that this carried is squared. So instead of writing it as a cosecant theta all squared, I'm just going to take it all at once. So there should be cosecant squared theta. That will be a divided by b squared. A divided by b is actually cotangent. So we should have a cot squared theta plus a 1. So this is what you got. This is the third trigonometric identity that you got. Now you really need to hold these trigonometric identities at the back because they're actually going to be so very useful. We're actually going to use them for many calculations and trig. So just try to bear it at the back.